Alright, you guys, lesson 99, absolute value inequalities. We did do these last year. You may not remember. It's been a while. Okay? So when you have an absolute value with an inequality, you're actually going to always end up with an and or an or graph. So and graph shaded between, or graph points out. Okay? So the first thing we're going to do is isolate the absolute value. So we're going to isolate the absolute value of x. So I'm going to subtract 3 from both sides. So I have negative, absolute value of x is greater than negative 3. And then we're going to divide by the negative. And when you divide by a negative, what do you have to remember to do? Okay, flip the inequality sign. Alright, once you isolate it, now you can actually determine if it's and or just by knowing the less than or the greater than. But you also can just do the next step, which is to separate it out into 2 different pieces. Okay? So what this is saying is that any number, okay, that's less than 3 is a solution, but also if I plugged in negative numbers, some of those would be solutions. Alright, some negatives, because they would be close to positive. Which negative numbers would be a solution? Just to think about it. Yeah, negative 2 and negative 1, because if you made those positive, they'd be less than, still be less than 3, right? But, so we always branch it out into 2 different pieces. The first one stays the same, but you drop the absolute value bars. So I always want to see this. And then the other one flips. So if I had less than, now it's greater than, and we make it negative. Alright, so the second one, you flip this, and we make it negative. Alright? That stands for those 2 numbers that are greater than negative 3 that work, right? Negative 2 and negative 1, those 2 numbers work. So we are doing a domain of integers. So we have less than 3 and greater than negative 3. So if you include both of these, did this end up as an and graph or an or graph? If you have to be less than 3 and greater than negative 3. An and graph, because I'm bigger than the smaller one and smaller than the bigger one. But we're doing integers, so we don't do 3 and negative 3. We just do the integers in between 3 and negative 3. So I have less than 3. That's going this way. Greater than negative 3. Less than 3. Okay, the second way to know that you have an and graph. Anytime you have less than, think of than as and. Weird, huh? Alright. So less than always gives you an and. Great for or gives you an or. Weird. Okay, let's try it. Okay, here we go. Write this one down. Negative absolute value of x plus 3 is less than negative 2. So first we have to isolate the absolute value before we can determine what kind of graph it is. And split it into 2 equations. So subtract 3 from both sides. And divide by a negative sign, which flips the inequality. So we get the absolute value of x is greater than 5. So because this is a greater than symbol, exactly, it is an or graph, right? It is an or graph. But I do want to see you split it into 2 pieces because there are 2 pieces that make this statement true. So the first one stays the same, but you drop the bars. And what would the second one be? Flip it, make it negative. So x is less than negative 5. So now I'm less than negative 5, greater than 5, which gives me the or graph. And our domain this time is real numbers. So we're going to do an open circle on negative 5. And it's a real number, so we're shading. And an open circle on positive 5 is greater than, so we go this way. We ended up with an or graph. Okay. There are some special cases. Okay, there's 2 special cases that happen with absolute value. Anytime you solve it and you isolate the absolute value and you get a negative sign, a negative number over here, then hopefully the bells go off and you're like, oh, I have to think about this one for Because for the first one, it says the absolute value of x is less than negative 2. So what are some numbers that are less than negative 2? Negative 3, negative 4, negative 5, negative 6. Can the absolute value of anything be a negative number? No. So the only solutions would have to be negative, but the absolute value makes everything positive. So what does that mean? No solution. You can put this symbol. This also means no solution. The empty set. Or you can put no solution. Pete, I'm guessing you'll probably do this one. At least some other work right here. Okay. Alright. And then the next one says the absolute value of x is greater than negative 2. So the absolute value of x is greater than negative 2. Absolute value is always positive, right? So if I pick like negative 100 and I plug that in, that becomes positive 100. Is that true? Is that a true statement? Yeah. 100 is greater than negative 2, right? How about 2? If I plug 2 in, the absolute value of 2 is 2. Is that greater than negative 2? Yeah. So is there any number that doesn't work? No. So because this is saying every positive number here has to be greater than negative 2, every single thing works, right? Negative 1 would work because that would become positive 1, which is greater than negative 2. So for this one,